Lesson 3, managing the virtual machines. We have this objective. After completing this lesson, you should be able to list and compare the different virtualization types. We show you the 3 main virtualization types that we have, and also we show you additional resources in which you will get this information or other types of virtualization that you have. The next topic is to identify and illustrate the various methods for creating virtual machines. We could create the virtual machines from scratch using the ISO images that contain your operating system. And in addition to this, we could create the VMs using cloning methods, simple and advanced methods. And to do so, you could use existing VMs, or if you want, for example, you could try to use templates or assemblies. Next topic is to manage virtual machine components such as disk, hot plug operations for disk, and network, and dynamic CPU and memory changes. Well, the way that you could modify at a later time the amount of virtual resources that you want. And in addition to this, for example, you need to extend storage, or you want to modify the existing storage array, and so on, and the effects of doing so, which are the actions that you need to take after that. And the next is to learn how to clone, migrate, and modify virtual machines. Well, the lesson overview, we have different sections. The first section of this lesson discusses about virtualization modes that are available for virtual machines, and the next section you explore the ways that you create virtual machines. We'll learn different methods we have. Sometimes we need to import or migrate the VMs that you have on existing virtualization systems to the Oracle VM server. And sometimes you have, for example, websites in which you are able to download templates and provision these templates in your Oracle VM infrastructure. And after learning how to create the virtual machines, you step through several types of operations on these virtual machines, including, for example, cloning, migration of the resources, and managing the whole life cycle of the VMs. Well, about the Oracle VM virtualization modes, it runs in one of these 3 modes. This is a para-virtualized mode, the PVM, the hardware virtualized mode, HVM, and the hardware virtualized mode using para-virtualized drivers, the PVHVM. There are many other methods or modes to run the VMs, but these are the 3 main modes that we will support with Oracle VM software. When creating a virtual machine, you could use the Oracle VM Manager user interface or the Oracle VM CLI. You choose this virtualization mode by selecting, at the time you create the VM, a domain type. In this case, there are choices much like Xen_HVM. This is for hardware virtualized machine or hardware virtualized mode. Xen_HVM_PV_ drivers. This is the hardware virtualized mode in which the VM you install or you incorporate para-virtualized drivers. And the other one is Xen_PVM. This is para-virtualized virtual mode, or virtualization mode. These are the 3 modes that we support. But in addition to this, the Oracle VM Manager for X86 architecture is able to view and to monitor virtualization that is supported on a Spark microprocessors. This is which are called LDOMs. So with Solaris Spark, okay, we also have the option to create something much like virtual machines, which are called logical domains. So this is why also you have the option to create or to discover VMs with this virtualization mode, the LDOMs_PVM. And unknown means that it's a virtualization mode that is not in or doesn't match with all of these 4 previous categories or modes. Well, about each one in detail, the para-virtualized mode. In the para-virtualized mode, the kernel is aware of the virtual environment in which it's working. Right? So in this case means that when you create the guest operating system, when you install the guest OS, the operating system is running in the virtual machine. In this case, you are using a kernel that is aware of the virtual environment. So it knows about the different virtualized resources that are offered by the DOM0, remember, and the Xen hypervisor, right? Well, the guest runs in the Xen_PVM domain type on the Oracle VM server. So at the time you create the VM, you need to select this domain type. The Oracle VM server does not require hardware virtualization assist in the system BIOS. So as you know, when you traditionally reboot or boot a server, you have the option to enter into the BIOS and to choose for the microprocessor in which the BIOS is running, which exactly the virtualization assistant that you want to choose. For example, BT threads or something like this, depending on you working with Intel or AMD microprocessor, you have the option to choose this option. So in this case, because the guest OS in the VM is aware of the virtual environment, this is why you don't require this hardware virtualization assistance. Because there is no emulated BIOS for the PVM guest, you cannot boot your guest OS using the emulate CD-ROM or DVD and an ISO image. So you have the option to create these VMs with this PVM mode. For example, using clones from templates, or for example, existing VMs, or for example, you have the option to perform the installation remotely. As you know, you have the option to install remotely using, for example, HTTP, FTP, or any other remote protocols or methods. Well, about discussing the virtualized mode in more detail about the advantages and disadvantages, I'm going to show you a support node in which we show you more detail this. Well, in support, we need to open a new website. And as you know, this is the website from support.oracle.com. We need to get logged in to the support website. So we provide the credentials. What you have in the knowledge type, for example, the support node. Well, this is the support node. I already make the search before for you. So you see this is the support node, the 757719.1. Where here is where we have the different modes, the virtualization mode that we support, all right? And if we scroll down, you will get which are the advantage and disadvantage. For example, the advantages for the PVM, okay, is the bit performance for 32 bits gets compared with, for example, HBM and HBM plus PV. This is, for example, for the older version of the Oracle VM server, and it offers greater maximum number of supported SCSI devices compared to the HBM, what support tens on devices that you could attach, for example, to the VM. About the disadvantage is lesser performance for 64-bit gets, only compared with the HBM plus the PV. It requires purpose will send you same kernel with PPM drivers, optimizes for example, virtualized environment, much like using non-unbreakable enterprise kernels for these Oracle Linux versions 4 and 5. The guest installation is only possible from exploded ISO images served from a network source, so not from virtual CD or DVD ISO image. No guest hub pages is support in the Oracle VM with this version, less than 3.2.4. Some functionality, much like, for example, ISO image import, is only available when the HBM capable of the Oracle VM server hardware, and some system kernel structure and features are not available when using the Oracle Linux PVM kernel. Well, the other mode is the hardware virtualized mode. In this other case, the HBM guest operating system can run completely unmodified. So in this case, what I mean is that you can install the operating system with using an ISO image, using a virtual CD and DVD ISO image, file residing for example, that is residing in a repository that is being accessible by the server pool, by this server in which you want to perform the creation or the installation of the Oracle VM. Well, in addition to this, the Oracle VM server must run on hardware that support virtualization, so you need to enable in the BIOS support for virtualization or virtualization assist, hardware virtualization assist, and there is a restriction on the maximum number of emulate integrate development environment, the IDs, and the SCSI devices. Again, making reference to the support node, You will see that these are the advantages. You have a simple installation upgrade using the standard vendor supplied installation media and updates. The standard gets installation from the CD-ROM and DVD image is supported. The Linux gets kernel support hub pages feature and also supports physical address extension, for example, functionality that's typical in Windows platform. The disadvantage is the performance overheating the hypervisor card translation, especially in the I/O and network calls. Also, the guest may prompt to clock skew timing issues. In this previous version has been solved in the most recent versions of Oracle VM Server. For example, guests cannot boot from SCSI devices or ID only. In this case, no SCSI BIOS person, and restriction on, for example, the maximum number on IDE SCSI devices. What you have, for example, here in this configuration section of the documentation, remember the release notes. If we go to the, for example, latest support, and we get the release notes of the latest version, much like the previous lessons, you will see about known limitations and workarounds, and in addition to these configuration limits. So we show you before, for example, about the maximum numbers for the servers, and for virtual matching maximums, you will see about virtual CPUs, the PVM, HVM, and if we go, for example, to virtual disk, you will see that the hardware virtualized driver only supports 4 IDI, including the CD-ROM, and 7 SCSI. PVM gives us, for example, a higher number of supported devices, up to 104. Well, and the other type of mode is hardware virtualized with a para-virtualized driver. Well, this is the best implementation. The guests are similar to hardware virtualized guests, but the guests can be configured to use para-virtualized driver for improved performance and for support more devices to be attached to the guest OS. For a guest running in HV mode, your Oracle VM server must still provide hardware virtualization assistance. So you need to enable this in the BIOS. These para-virtualized drivers need to be installed in your guest. For example, the current releases for Oracle Linux, you have in the kernel the option to provide the kernel with the pre-installed para-virtualized driver or not. It depends, for example, when you change the para-virtualized mode or hardware virtualized mode during the creation of the virtual matching, or for example after that, automatically detect the change, and when you reboot the VM the next time, it automatically chooses the kernel that you need to use to work with PV-HVM or, for example, HVM mode. For Microsoft Windows platform, you have MSI, Microsoft Installer utility, that you perform the installation of these para-virtualized drivers on the Windows guest OS systems. You can install the OS in your guest by using a virtual CD-ROM, a DVD, and selecting an ISO image. Well, if we go to the support node, again, you will see that for the PV-HVM, also you have the following advantage and disadvantages. Best overall guest performance compared with HVM and HVM plus PV, the right this performance, for example, in this previous, the HVM unwrappable enterprise kernel guests are automatically configured, and HVM plus PV for optimal performance. This is the main key differentiation of the, for example, creating a virtual matching with the Oracle Linux kernel. It comes with a simple installation upgrade using a standard vendor simple installation media. Standard installation using virtual CD-ROM, DVD, ISO image is supported, and Linux guest kernel support hub pages, Linux guest kernel support PAE, and guest still retains all system kernel structure features provided by the hardware virtualized mode, despite use of the PV drivers. Well, about disadvantages required add-on, for example, the key mode kernel mode PV-HVM or the key mode Shen PV kernel driver packages to provide the para-virtualized drivers. Well, this is, for example, for the Oracle Enterprise Linux 4 and 5 versions in this case, right, that are less than these versions with these updates. And it requires, because for the newer versions it doesn't require this. Remember that the kernel automatically change when you reboot and you choose the virtualization mode, and it requires significant gets modification, including add-on packages with PB drivers. There is some issue prone for also these versions that there's less than for Oracle Enterprise Linux 4 update 7 and Oracle Linux 5 update 3. Well, you will also have in this support note what to do if you have a Linux version, as they gave us, less than these versions. It's the manual steps. You need to be careful about the steps that you do, but you need to perform the installation, you need to perform some parameters in the kernels, compile some libraries that run so on. But starting with the versions that are greater than this, that I show you in this support note, you will see that automatically choose the new kernel, and you need to do practically anything. All right. Well, this is you see a nice note in which you will get or you will extend more. In addition to this, we have another website from the Zen project, which is wiki.zen.org. This is the open source project for the Zen operating system. So you have in the wiki.zen.org different resources. One of these, for example, is about comparisons or features compatibility. So here is where you get comparisons of different virtualization kernels, much like Zen, XCP, right? And about the features that you have with Zen, you have this link, the Shen feature list. And in the Shen feature list, so as different Shen versions, right, that we have. And in this version, for example, they support 4 guest types, okay, the virtualization modes. To know exactly which is the version that we have, if we go to the remote environment and we open a terminal, we block as the root user, and for example, we connect with the OBS server 01. Remember that this server as root with password Oracle. This server is the server that we're running. You see that for the labs we are not running the latest version, as I showed you before in the documentation. This is the latest version that we have, 3.4.3. All right, so we are working with this one, okay, 3.4.2. Well, in this case, for example, if we execute the message and we grep, for example, the same version, okay, we should get which is the same version. You see that we have a different version or release than, for example, the same project, right? Because Oracle VM server is based on Shen. Okay, for us we are using this release, but it's important to know which is the, for example, same version that is included, right? So for example, to know which is the version is this one. It helps us, for example, to in the website for the same project, to know which is the same version, which is the supported, and for example, for guest types, it shows us information about more detail. Okay, the Zen, just the way you see, you have the domain 0 with the tool stack, the DOM 0 kernel. It comes with drivers to work with the hardware, all right? You have the hypervisor. This is the layer about managing scheduler, key memory, timers, interrupts. And the domain 0 is the way that shows us the backend and front ends for I/O and for block and net. Block means that is for disk, and net is for network devices. So these devices are network devices. And the virtual machine, you see, is able to work with or without the paravirtualized driver. It depends if we work with PBM, HBM, or HBM plus PBM modes. That's right. Well, also it shows us for the guest types more detail about the supported method. You see that I showed you before that you also have the option to choose unknown, because you see in addition to HBM, HB plus or PB, HBM and PBM, right, you see that we have other, much like PB or PBH, okay? And also it shows us, for example, about this network, interrupts and timers, emulate motherboard, privilege instructions, and page tables, right? If it's supported or not. If, for example, you have performance, scope for improvement, optimal performance, and again in more detail, okay, the different virtualization modes. Well, use it as a reference to help you to get more detail or to extend this, right? Well, obviously sometimes you start with a virtualization mode that you want to change to another one. Well, so for example, you can convert an HVM guest to a PVM or PV-HVM. Remember that for Microsoft Windows, the guest can only run as HVM or PV-HVM. This means that it runs without any another action as a HVM guest OS, or with PV-HVM. Remember, you need to install the Microsoft Windows para-virtualized drivers. What to do is show, if we go to delivery.oracle.com, the website to download software. We may click on sign in. We have this section, Linux OVM. So for Oracle VM, we have the Oracle VM 7. So we choose this one and we select the platform. For example, this platform, and we get this selection. We may click on continue. And you will see that we have, for example, the latest release 3.4.3. And if we expand, you will see that we have the Oracle VM server for X86 Windows PV drivers. So, for example, we choose only this one, and we may click and continue. But remember, you are under some license, so you need to check this and agree. And after that, you will see that this is a zip file that comes with an MSI, Microsoft installer, that you execute in the Windows guest OS after it's installed. All right, or for example, convert it from a physical machine to a virtual machine or clone. All right, and in this way, that's the way that you enable or you convert hardware virtualized to a para-virtualized hardware virtualized guest, right? If you are running a current version of Oracle Linux or the Unbreakable Enterprise kernel, you can change the domain type of your virtual machine from HVM to AVM. This is a simple step, that's easy, but you see that older Oracle Linux versions, I explained you before in the support note, require additional conversion steps, and they are described in detail in this support note. Well, why it's supported with the most recent version of Oracle Linux, the change of the virtualization mode in an easy way. Basically, you need to edit the virtual machine, you modify the virtualization mode, and you reboot the VM. This is because these Oracle Linux versions comes with the PBOps kernels, which are kernels that contain both the para-virtualized driver as well as the native device drivers. So the native device drivers are used when you're running your virtual machine and as a HVM guest. All right. And it comes also with the para-virtualized drivers if you want to change this virtual machine to a PV-HVM virtual machine. So by default, an HVM guest with a props kernel runs a fully virtualized with PV drivers. You can force, if you want, the Oracle Linux guest to run as pure HVM by adding this parameter, this send_emo_unplugged equals to never to the kernel entry in the group configuration file that is located in this directory. Well, next step is to creating virtual machines. So the next section in this lesson addresses about virtual machine creation. You can create a virtual machine by different ways. So one of these is using an installation media. The other one is, for example, importing virtual resources, much like the operating system image files and software image files and additional image files, and creating or importing, in addition to this, the configuration file for the virtual machine. Another very nice method is to convert a physical machine into a virtual machine using the P2B utility that comes with the Oracle VM software, and creating your own templates or virtual appliances using specific software, much like Oracle Virtual Appliance Virtual Builder Assistant, and cloning these resources into new templates or virtual appliances. Okay, for creating a virtual machine by using the installation media, you create a virtual machine by using the Oracle VM management interfaces. So you could use the Enterprise Manager, the Oracle VM user interface or the Oracle VM command line interface. Well, after that, because remember it's only supported the hardware virtualized or hardware virtualized with paravirtualized drivers, you need to select this virtualized mode, right? The zen_hvm or the zen_hvm_pv_ drivers domain type from the Oracle VM Manager user interface. After that, you need to add at least one disk device as a CD or DVD. So you need to select as the boot option this CD or DVD, and you need to attach the ISO image file to this virtual CD or DVD. If you select the Zen PVM as a domain type, remember that you have no option to emulate a DVD or CD device. So we need to prepare the access to the installation media from a remote location. You typically the provider of the operating system, much like in this case Oracle Linux. You have the option to create a YAML repository which contains the packages with the kernel and the different packages with utilities and libraries needed by the operating system. After that, we need to select the PXE as the boot option during the creation of the virtual machine, and we need to provide the HTTP or NFS path to this remote exploded ISO file. Well, so in this YAML repository, you need to enable the option to get access, for example, with an Apache web server or as an NFS share mount point, right? The way to get access remotely. So this information needs to be provided during the installation. Well, the other way is to create exactly the same way the virtual machine using an ISOMH. But what's happening if we use the CLI? Well, the previous slide was about using the user interface, but with the CLI you create a virtual machine using the create VM. That's the way that also you need to provide additional commands in the CLI to, for example, map a disk with the ISO file. All right. Well, so the way is that you need to add a virtual disk by using the create virtual disk command. So you specify the disk name, the size, whether to use a sparse allocation or not, and which is the target repository. For the creation of the virtual machine, you need to specify the name, the domain type, the memory, the repository in which the configuration file is going to be stored, the boot option, and the server pool in which it's going to be running. And after that, you need to create a disk mapping. That's very important for an existing ISO file by using the create VM disk mapping command. This ISO file needs to be uploaded previously into a repository that is being accessible by the server pool in which you are creating the virtual machine. So you need to specify the disk slot, the ISO file disk name, and the target virtual machine. And practically that's all. After that, you start a virtual machine by using the start VM command. You have more details in the notes of this slide to do show. Another way is to create a virtual machine by importing virtual resources. So you can import a template. It's a file that contains the virtual disk, the image disk with the operating system and additional software. And in addition to this, the configuration file in which you describe the type of the virtualization, the domain type. In addition to this, the name of the virtual machine, the amount of virtual memory, the number of virtual CPUs, maximums about this, the boot order, the mappings to devices, network interfaces with virtual NICs information about MAC addresses, and so on. Well, another way is to use a virtual appliance. Appliances are the most modern way to create templates. And today you have software much like Oracle VirtualBox, in which you are able to create virtual machines and export these virtual machines as virtual appliances. Also, there are multiple providers, including Oracle, that use clouds to show you the way that you are able to download templates and virtual appliances. Also, you can import a virtual machine, so you need to provide the files and the configuration file to do a show. Also, you could import virtual disks, so you create a new virtual machine from scratch with this virtual disk, and during the assistant you create a configuration file. So basically you need to attach these virtual disks. It's easy, for example, if you have system images that contains operating system, other file images that contain software, and it's very easy to clone, copying making copies of these files and to uploading this into the repository and to attaching this to the creation process of new virtual machines, and also by using the Oracle VM management interfaces. So you could use the Oracle VM Manager user interface and the Oracle VM Manager command line interface. Well, the other way is using the imported templates, virtual appliance, or virtual machine. You create the new virtual machines by using cloning. It's important to know that they works as a source, okay, for the operation to create the new virtual machines. So this process is cloning. What you get is a binary copy of these template contents, virtual appliance contents, virtual machine contents, or virtual disks to deploy the virtual machine. And the other way is you import individual virtual disks. You create a new virtual machine and add the virtual disks to the virtual machine configuration. Well, you start a system and you need to follow the workflow with different steps. And for the step about disk, basically the operation that you need to attach these virtual disks that you imported previously for performing the clonation, right? Well, about importing templates, you have multiple ways to do so, but when you import a template, you can, for example, import a single compressed file. It contains all the components of the template. You do it so specifying typically the URL or the FTP location for this file. You could or could not have access remotely to internet, for example, with a proxy server or not. So it depends the way that you provide this location. So it's easy, for example, to in a server to provide or to perform the installation of an Apache web server, for example, and to provision the templates there, to stage the templates there, and use this URL as the location for importing the template. Well, as a single compressed file, typically is a tar gpet file, a tgset extension file or suffix file. So in this way you will see that it contains typically files much like an image files, .img, that contains operating system, for example, Oracle database software, Oracle Fusion middleware software. So you have multiple image files. There are treated as virtual disks, right? And in addition to this single compressed file contains the configuration file for the virtual machine. Okay, the attributes of this virtual machine, and it has the name of vm.cfg. Another way is to import all the components in a non-compressed way for the template. So not only you have the option to specify the tar gpet file, single compressed file, also you have the option to provide each one of the different components per line, okay, in the assistant. So you see an example, with the FTP protocol, you have the option to specify the location of a system.image file, typically the virtual disk that contains the operating system. In another line, you have the option to provide the vm.cfg file, much like in the example, that contains the configuration information. So when you are performing the clonation of the virtual machine, it inherits these values and automatically populate these values in the different text fields of the system. And during the import operation, you need to know that the template is decompressed if it's needed, for example. It does this automatically. Obviously, it spends time, so you will see that you schedule a job with the Oracle VM Manager user interface that it spends a lot of time trying to import in and the compression. So it shows us exactly in which step of this process is doing. Also, the configuration file is stored in the templates directory, and the virtual disks are stored in the virtual disk directory. Remember, when you import, you need to specify which repository. So it automatically uses these template and virtual disk directories of this repository to store the configuration file and the virtual disk. Well, if you want to import a virtual appliance, you can import, for example, the virtual appliance file, which is typically packaged into an archive file with this extension .ova. Well, you have tools or other software, much like Repeat Oracle VirtualBox, that do that in this way. When you create a new virtual machine with Oracle VirtualBox and you export the virtual machine, you create a template such as a virtual appliance. With the components of the virtual appliance, typically is they are the virtual disk that they are in raw format, and in addition to this they contain the OBF file, which describe the information about this appliance. So as the first step, import this virtual disk in raw format. Well, depend on the virtual disk type that you are using. For example, with Oracle VirtualBox, you have the option to create different types of virtual disks with different extensions. For example, VM, the key, or VHI, and so on. You have multiple types, but these types are not treated as a raw format. So you have a tool which is the KeyMove-IMG. This utility helps you, for example, to convert virtual disks in non-raw format, in, for example, vendor-specific format, to this raw format. So in this way, it should be able to automatically do this. If you import in other formats, or Oracle VM automatically, the manager automatically convert by you, right? So you need to take in account that this process should be slow down the import operation if you have been done those before, right? And the second step is to import the OBF file. You can view the contents of the virtual appliance by using the tar command. So the OVA file is much like a tar file, right? So with the tar utility, you are able to view the contents. So you will see the virtual disk, the image files, or the files that contain the operating system with other extensions. And in addition to this, you should be able to view the OBF file. After importing the virtual appliance, you can create a template from one of the virtual machines in the virtual appliance, or you create a virtual machine directly from the virtual appliance. What I mean is that you need to creating a copy, cloning the process. You cannot, after you import a virtual appliance, to use this as a virtual machine, right? You need to use for cloning process, for provisioning process of virtual machines. Well, other way is to import a virtual machine directly. So as you know, virtual machine contains image files and a configuration file. So you need to specify the URL of each component of the virtual machine. So you have the option to provide the image files and the configuration file, or for example, for a single archive file. If you use a utility much like a tar with the zipped option, you have the option to compress yourself and to package yourself these image files and the configuration file, and to provide the location of this tar zipped file to import a virtual machine. After you import the operation, the virtual machine appears in the setup pool or in the unassigned virtual machines folder. Why? Because you have the option to import a virtual machine as an action, as a menu option that you have in the toolbar, in putting focus or taking the action from a setup pool, or you know that, for example, in navigation pane of servers and VMs, also you have an assigned virtual machine folder. So if you do from this putting focus on this section in the navigation panel, the virtual machine appears here. Well, also another option is to import only virtual disk. So if it's necessary, I repeat, if this virtual disk comes from other virtualization vendor platforms, you could use the KeyMove image. You have an example like this one. So you convert, for example, from this format, BMDKey, to raw format. Okay, and the resulting format you see is the .img file, right? So to import the virtual disk, you need to make this virtual disk available from a remote location using HTTP, FTP, NFS protocols, and you use the import virtual disk wizard from the Oracle VM Manager user interface, or you have the option to use import virtual disk from the Oracle VM CLI. After importing the virtual disk, okay, you can create a virtual machine, and then you can, during the process of the assistant of the creation of the virtual machine, you can attach this virtual disk, okay, during the configuration process. In addition to this, virtual disk should appear in the repository from which you are importing this virtual disk, right? Well, so you have learned about different methods we have for importing templates, appliances, for importing virtual machines, for importing virtual disks, and how to use it after that, right? In this quiz, which of the following is a valid way to create virtual machines with bootable guests? By cloning a template containing a bootable virtual disk, that's true. By installing from installation media, That's true. You have the option to choose the boot order and select the CD or DVD that you emulated. By importing, or PXE, for example, for HVM that for PVM that doesn't support the installation using a media file, right? By importing an appliance from another virtualization platform, that's true. And by importing a bootable virtual disk and including this in a virtual machine, so that's true. So the correct answer to this question is E, all of the above. And that's all for the first part. And this is the end of the lesson 3, part 1. Next step is creating a virtual machine by using the P2B utility. With this utility, you transfer a computer's operating system. You have a physical machine with the operating system installed. You also have applications. So typically this matching comes with a different hard disk, and in this disk you have the operating system, the drivers, applications, and so on. So you transfer this to Oracle VM template, and the domain type is set to HVM. You know, after that you transfer to a template, you could create a VM, and if you want, you could modify this domain type to another one, a PVM or a HVM with PVM. When running the P2B utility, you have an assistant that you stripped through different steps or the following stages. The configuration stage, in which you need to provide some attributes or parameters. This is for creating the configuration file for a virtual machine, the vm.csv file. Also a collection stage in which you need to choose the different hard disk, the drives, to be imported and to be included in the template, and the import stage in which you get the template created. After completing the transfer, you could edit the template and change the settings as is needed. And in addition to this, or you should be able to create a virtual machine and add the virtual disk created by the P2B utility to your virtual machine this configuration. Well, to do so, we have more details in the documentation. Remember to go, for example, to the documentation in docs.oracle.com. We have different sections for different product areas. You have database, middleware, and you have a specific section which is virtualization. So we may click in virtualization. You have the documentation for the Oracle VM server for X86 and the Oracle VM Manager documentation. So here you could choose, or you could download the documentation, for example, for the latest release, if we view the library. And here you have the installation and upgrade guide. So in this documentation is where you learn how to perform the installation of the products, all right? And in the administrator guide, in this other, here is where you have this section, converting physical hosts to virtual machines. And we have an introduction to the utility and how, for example, to convert in the host in interactive mode. Well, usually with the Oracle VM Server ISO image, you will see that you perform the installation of the VM servers, but in addition to this, you have the option to launch the P2B utility. So in the existing hardware, the existing physical server with the existing operating system that you want to extract the operating system and application and to create a template based on this, you after you boot the server, the physical server, you will see that in the boot menu you don't need to press enter because it's to install the Oracle VM server. That's it, but this is what we don't want to do. What we want to do is to extract the existing operating system and applications into a template. So you need to type P2B. After you type P2B, you enter into an assistant in which you need to be prompt about TCP/IP settings. Remember that at the end, what it does, this P2B utility, is to implement an Apache web server that shows you the option to extract the contents of the physical servers. So you need to choose this information. After that, you need to choose the different physical disks that you have in the physical server. So for example, we have one, but you have multiple. You see, you could press the space and select with the start multiple disks to be imported. You get into the following assistant steps, providing configuration information, for example, the name of the virtual machine, the memory, the virtual CPUs, which is the console password, all right? And at the end, you will see that it's starting the web server, and you get remotely to this. So when you are going to import, you see when you get access to this web server, remember that you set up this IP address, that's right, you will see that it lists the content. So you have the configuration file with the data that you introduced previously, and in addition to this, all the different hard disks you see are shown as .image files. And basically that's all. So you are able, for example, to import a template providing one by one, or if you want, you are able to download and to zip the files, and after that use the tar utility to create a template file to be imported later. Well, another way is to create a virtual machine by creating your own templates and virtual appliances. So you can create a template using one of the following processes. For example, you create a package with the vm.csv file. You could take this file from existing virtual machines. You could create and download it, for example, in your laptop and edit manually. And also any existing disk images that you have. Also, you can create a template from a virtual machine. So, okay, you, for example, do it so, and you see that you perform a minimal installation of the Oracle Linux as needed. Also system and application package in this existing virtual machine. You could use the virtual machine guest additions, for example, to trigger configuration at first boot. Well, basically this we will explain later in the next lesson, but it's the way that, for example, you with this first boot and this guest addition, you are able to change the name for the host. For the new virtual machine, you have the option to specify a network configuration, much like the way you get the IP address statically or dynamically with the HTTP to provide DNS servers, and also to provide or change the root password. Well, after that, you could convert the virtual machine to a template, and you can create virtual appliances by using, for example, Oracle Virtual Assembly Builder. This is a utility that we have in which you should be able to design also the virtual appliances. Or you could get, for example, from Oracle. You could create a virtual machine by migrating virtual machines from other platforms. So, as you know, many virtualization products support packaging. They comes with their own tools to do so. All right. So typically with these tools, they are able to convert existing virtual machines in these other vendor platforms into virtual appliances. So after you have the virtual appliance file, typically it's a file with the .ova extension, you can import this file into the repositories that you have using the assistant, the import appliance assistant that comes with the Oracle Manager user interface of the CLI. And after creating or obtaining this OVA file, you import a virtual appliance, you create a template from one of the virtual machines in the virtual appliance, and you clone this template to create a new virtual machine or another template. Remember, you could clone existing templates into virtual machines or into other templates, and you could create a virtual machine directly from the virtual appliance if you want. Well, other way is to create a virtual machine by using cloning. So, well, this is the process of creating a copy of the existing virtual machine or an existing template. Right? So, as a result, you have a new virtual machine based on these source objects. Where you clone a virtual machine, you have the way that it depends where the existing template files or virtual machine files reside. So for example, with virtual disk residing in the OCFS repository, you use a reflink operation. Also, which is called a fast copy operation. So you get benefit of this functionality, this reflink functionality on the OCFS2 repositories So the way you save time in the process of cloning, creating a new virtual machine based on these templates. And a new clone obtains a new object, unique universal identifier, and a new MAC address for each cloned virtual NIC that you create. Well, when you perform the clonation, you have two ways to do so. You have a simple cloning or advanced cloning. For simple cloning, if you're performing this operation, the clone is created exactly like the source object. So you get exactly the same virtual disk and the same networking about virtual NICs configuration. For the thin cloning, for example, to take place with the simple cloning, all components in the source object must reside in the OTFS repositories, or for example, vendor managed storage that support thin provision. And as you know, we have the storage connector initiative that give us the option for multiple storage vendors to develop plugins that we are able to install in the Oracle VM servers. Remember, typically the utility servers, because they do these importing operations, right? And in addition to this, there are being installed in the Oracle VM servers with this role that are used to create the virtual machines. So in this vendor managed storage that supports thin provisioning, also you perform a fast copy operation, much like in the OTFS2 repositories. Well, for simple cloning, you see is a simple step, and you need to provide a very few information during the process. The other way is to use advanced cloning. Okay, for advanced cloning, we work with which are called clone customizers. So you could create different storage and network mappings. It's the way that, for example, when you are cloning a virtual machine based on a template on an existing virtual machine, you want to add or remove virtual disk, and also you want to add or remove virtual network interfaces, virtual NICs. And the most important, the mappings is about, as you know, you create virtual machine networks with the network tab using, for example, the Oracle Manager user interface. So with advanced cloning, you have the option to choose exactly which virtual machine network will be used by these virtual NICs in this virtual machine. And for the storage, it's exactly the same. As you know, you have a virtual disk. So with simple cloning, you use the same repository, but if you want to use different mappings, for example, use different repositories that are being accessible by the VM servers in which you want to run this virtual machine you are cloning, you have the option to choose different. And for example, also you have the option to add additional LANs or to map different LANs that you have in other fiber channel or iSCSI storage components, right? All advanced cloning operations require the use of this clone customizer. You have the option to create new clone customizers, to use existing clone customizers, so you typically need to perform some administration tasks about managing these clone customizers. And you can reuse a clone customizer if, for example, all the storage areas for these mappings support thin provisioning. And if the source object that you want to clone has a shared disk assignment, you don't need to map these shared disks in the clone customizer. Well, the problem when you are cloning a template or an existing built-in machine that contains mappings to disk that they are shared by other VMs, is that during the cloning process, if you don't remove these mappings, the cloning process also clone these shared devices, so make no sense. Obviously, if it's shared, you have only one that is used by multiple machines, so this is why you need to remove this mapping. And after you create the VM, what you do is to edit the VM to map, to create new mappings to these existing shared disks. Well, in addition to this, after you finish with the cloning process, you are able to perform some operations on the virtual machines. Well, so in the first section, you learn about the various ways to create the virtual machines, but in the next section, for example, you are going to learn how to migrate virtual machines, including performing the live migration, also how to protect the virtual machine resources, and how to make changes in to the running virtual machines, like changing the virtual CPUs, changing the attached disks, right, and so on. Well, about migrating the virtual machines, is the action of moving a virtual machine from one VM server to another. Remember that it depends on the type of repositories that you use, but for ISCSI or Fiber Channel repositories, you could migrate VMs only from one VM server to another that they are members of the same server pool. If you use an NFS repository, you could migrate VMs from a server to another that they are members of different server pools. If the virtual machine is running, the move operation is called live migration. What it does is basically move the dirty pages from memory from one server to another, and it's secure. What I mean is that it's encrypted. Remember, you have the option to create a dedicated live migration network, for example, to improve the transfer operation of these dirty pages from memory from one server to another. Live migration can be triggered from any of the Oracle VM management interfaces using the user interface of the CLI. Also, remember, if you implement DRS or DPM policies, maybe you do an action to this. Remember, because it tried to load balance the workloads, or for example, it tried to save power if it has enough resources in existing VM servers to support or to migrate the VM to this and to let to others, okay, to have no VMs and to power off to save power, right? And when the Oracle VM server enters in maintenance mode, you need to do some tags about maintaining hardware or software in the VM servers. So when you set this option, remember it's an option that you have in the menu. You make right-click mouse button in the server, and you have the option to choose maintenance mode. When you enter into maintenance mode, automatically before entering in this mode, it starts to migrate all the existing VMs running in this server to other server in the server pool. What about live migration? You need to take in account that the virtual machines can only live migrate, can only be moved from one server to another, that they belong to the same server processor compatibility group. Remember, this is created automatically by the Oracle VM server infrastructure when you discover the servers with the Oracle VM Manager. Live migration of virtual machines using hard partitioning is not permitted because this is under the terms of the hard partitioning license. So you need to take in account this about the live migration. Well, you could do it manually if you want, for example, for maintenance, but it's only for a short period of time. But you cannot left to the system to do a show based on, for example, DRS or DPM policies or a manual operation that you do. And you could use you can use the live migration for virtual machines in an Oracle RAG deployment. Well, you have the notes in a specific document because when you are migrating VM in which you have a RAG instance from one server to another, the process needs to take time to do so, and during this time it's moving all the DT pages that contains the Oracle database instance with the database blocks and internal information or resources from one server to another. So it's much like to have an instance during a small period of time, a specific period of time, unavailable. So obviously it should affect, for example, that applications that are being balanced between multiple instances in the rack, and so on. So what you need to apply some best practices and to perform some changes in the configuration as explained and repeat in the PDF that you have in the notes. Well, about protecting the virtual machine resources with the inbound migration log, well, based on these, for example, policies, DRS or DPM, or for example, you try to do it manually, sometimes you have in a server VMs that they need to have practically exclusive access to the resources in this VM server, CPU and memory. So for example, you want to avoid some VMs that they are running in other VM servers to be migrated based on these policies or manually. You have the option to avoid this with this inbound migration log to avoid migrating VMs to this server, which is specifically designed or implemented for specific VMs, right? So you can use this inbound migration log feature to protect the resources allocated to one or more virtual machines that are running in an existing server that you want to use for host other VMs. So you activate this feature at the VM server level with the edit function. Well, this option cannot be implemented graphically, so you typically edit this function with the CLI tool. This feature blocks action that can reduce the resources on this VM server where the virtual machines are running, such as, for example, the creation of a new virtual machine or the migration of existing virtual machines to this server, from other servers to this server. And other mechanisms that trigger migration actions, such as DRS and DPM, comply with the inbound migration log feature. So at the end, the inbound migration log feature override any other migration action to avoid this. In addition to this, making changes to a virtual machine, okay, you can, for example, after you have an existing virtual machine created from scratch using a template, using an existing VM, you can, for example, add network devices. You can attach additional virtual NICs with their own MAC addresses. You can add or remove virtual and physical disks. You can attach LANs. You can attach virtual disk image files, right? You can add or remove virtual CPU resources. Remember that you have a maximum that you cannot change, right? But you should be able, for example, to increase up to this maximum, okay? If, for example, the initial number of virtual CPUs doesn't reach this maximum, right? Also, you could increase and decrease the virtual memory. Also, much like the virtual CPUs, you also have a maximum for the memory, and you could do it show dynamically if you want up to this maximum. And you could increase the size of virtual disk or LANs. It's important to know that, for example, if you want to increase the size of virtual disk, it's not the same as LANs. If you do it so, you need to reboot the virtual machine to take effect, so you will reflect the new increase of this size, right? You know that, for example, using live migration is a good way to, for example, to refresh this new size and to show you, for example, with the DF utility, okay, this new size. For LANs is different. For LANs is different because you can do it. You could increase the size, and with the part-proof utility, automatically you update the new size, so the operating system is aware of this new size. So you see it's different for virtual disks than LANs. And the ability to make the change depends on the virtual machine domain type and the guest OS. About detecting, for example, these new increases, for example, about changing the CPUs or the memory dynamically without the need, for example, to rebooting the VM. And also the domain type, remember, about, for example, limits of extending the number of attached physical disks or virtual disks, or, for example, network devices. So you, as showed before in the documentation, okay, you could get access to these known limitations and maximum values, right? Well, about the virtual machine lifecycle, remember that you have the option to take some actions like a start, stop, pause, resume the VMs. So virtual machines in your Oracle VM environments step through stages that are similar to those experienced by the physical host. You can design a test production lifecycle for your virtual machines by dedicating the servers for the test cycle and move these virtual machines to more powerful servers, for example, they are in production. So it helps you to do this testing because obviously they have the same states that, for example, you have in physical servers, but it depends about the behavior of the software that you have. If the software it runs in single mode or standalone mode, if it runs in cluster, for example, rack database software, or for example, cluster web logic domains or something like this. So this way is very good for you to test the behavior of the applications before, for example, changing the state of the VMs, much like pausing, much like resuming or rebooting, or for example, migrating. Well, in the lesson about, you have title about operations, okay, you explore ways of reconfiguring your environments to respond to the changing needs of your environment. Well, in the operations, you will learn more detail, for example, what's happening with repositories, what happened with servers, they are added, they are removed, they are changed, all right? That also should affect to the virtual machine lifecycle. And finally, we have a quiz about live migration of a virtual machine can be triggered when an Oracle VM server enters into maintenance modes by a DRS or DPM policy, by a migration request from one of the VM management interfaces, by a request from within a virtual machine. So like migration is when the Oracle VM server enters into maintenance mode, that's true. By a DRS or DPM policy, that's true. By a migration request from one of the Oracle VM management interfaces, that's true, you could do it manually. And by a request from the virtual machine. Well, so is A, B, and C, that's right. These are the different options that are true, all right. Well, so that's all, and as a summary, in this lesson you should have learned how to list and compare the virtualization types. You have hardware virtualized, para-virtualized, and PV-HVM, para-virtualized drivers with hardware virtualized. Also to identify and illustrate the various methods of creating virtual machines from scratch, installing the operating system using a DVD, or for example with the PXE protocol, creating from a template or from an assembly or from a virtual disk that you imported manually. Also how to manage virtual machine components such as disk, which are the hot plug-in operations for the disk and network. What's happening if you attach an additional virtual link, you attach an additional virtual disk or LAN, how to dynamically resize or change these parameters, and also how to dynamically change the CPU resources and the memory. And finally, how to clone, migrate, and modify the virtual machines. So that's all for the second part of the lesson 3. Practice 3.1, create virtual machines by using cloning. This practice, you start a session to the Oracle VM Manager user interface and you create 2 clones, one from a virtual machine and one from a template. You configure both clones to access the VM_net network on the 192.168.1.0 subnets. In the assumptions, this practice assumes that the following objects are already present in the ISCSI_repos1 repository. Virtual machine named ISCSI_PVM1. The virtual machine is running Oracle Linux 6 Update 5 and was created by using the installation ISO file for Oracle Linux 6 Update 5. Virtual appliance called OVM_006U5_X86_64_PVM.OVA. This virtual appliance contains a virtual machine with Oracle Linux 6 Update 5 installed and a template that was created from the OVM_OL6U5_X86_64_PVM.OVA virtual appliance. Well, we've had the following tasks. First one, we need to access the Oracle VM Manager user interface and display the virtual machines in your Oracle VM environment. So we'll log into your lab machine and open a terminal window on your desktop. Okay, now we change the user to root with -. We enter the password that the instructor provides you. After that, we access to the ovmmgr01.example.com from your lab machine by using the ssh-x command. ssh-x ovmmgr01. No, without that, it's okay. And password, remember, is Oracle. We start a Mozilla Firefox session from ovmmgr01.example.com and we use the -node-remote option to forward the Firefox window from ovmmgr01 rather than using the local Firefox on your lab machine. We wait to appear the Firefox. So we enter the URL for the Oracle VM Manager user interface running on ovmmgr01.example.com. It's https://localhost 7002/ovm/console. What login page appears, so we need to get login as admin and password my Oracle one. The servers and the VM tabs display. We click the Half tab and verify that the two Oracle VM servers are in a running state. The two Oracle VM servers must be in a running state to continue. So we see that all the VM servers and VMs in a normal state. Okay, so we have in the pool one, two servers running of a total of two. In the navigation pane, we expand the server pools folder and click pool one and select virtual machines from the perspective drop-down list in the management pane. So we select servers, we expand server pools, we choose pool one, and in the perspective drop-down list, we choose virtual machines. So there are two virtual machines in the server pool. Pool one, virtual machine ISCSI_PVM1 was created by using the Oracle Linux 6 Update 5 installation initial image. This virtual machine is running. Well, if it's not, okay, because it was stopped, for example, in my demos or something like this, you may click on start. All right, and the virtual machine NFS_PVM1 was cloned from a template residing in the ISCSI repository. This virtual machine is stopped. Well, we stop the ISCSI PVM virtual machine by highlighting in the management pane and clicking the stop icon. Well, you will see that this is the normal step I showed you before, right? So we need to make click on stop. Well, you get a confirmation message. All right, so we make click OK in the confirmation window. So the ISCSI_PVM1 virtual machine take less than 1 minute to stop. Well, next step is to clone the ISCSI_PVM1 virtual machine, to rename it, to start it, and to examine its network configuration. So we highlight the ISCSI virtual machine in the management pane and we select the clone virtual machine icon. Well, so in this highlighted, we need to choose the clone operation. Well, you have this option, clone virtual machine. In the clone virtual machine ISCSI_PVM1 window, we enter the selection as summarized in the following table, where first of all, clone to we need to select the virtual machine ready button. Clone count, we select 1. About the clone name, name index is 0, and the clone name we need to enter ISCSI_PVM2. Description: virtual machine created by cloning the existing ISCSI_PVM1 virtual machine. Well, we do not select advanced clone, and what the target pool, obviously we have only one. Okay, we choose this one, right? What show? You need to check the information: virtual matching, clone count, name index, ISCSI_PVM2, virtual machine created by cloning the existing ISCSI_PVM1 virtual machine. Well, we may click on OK to trigger the cloning operation, and the cloning operation takes 10 seconds or less to complete. The virtual machine ISCSI_PVM2.0 appears in the list of virtual machines in the pool 1 server pool. Okay, you see here. Well, we need to rename. Also, we check that the job about clonation was executed successfully. Now we need to rename the clone to ISCSI_PVM2. So we highlight the new clone and we may click in the edit icon. This one. So you have this, and on the configuration tab, we delete the extra .0 characters in the name file. After that, we may click on OK to trigger the change. So we schedule a new job about modifying. Well, we examine the settings for the new virtual machine by clicking the expand button next to the virtual machine name in the management pane and by clicking the configuration, network and disk tabs. So we expand this, and what you could, for example, make click here to hide the job panel to get more detail about the configuration. So this is the following screen, shows that the network information. So during the cloning process, the new virtual machine, the ISCSI_PVM2, acquired its own virtual NIC and has a different MAC address than the MAC address of the source virtual machine, ISCSI_PVM1, used for the cloning operation. Well, we could check this. For example, you see that we have a 00 and it's ended by 1B. If we choose the PV1 that we clone and we expand and we go to networks, you will see that the MAC address is ended by EB. So it's the way that we demonstrate that during the cloning operation, it takes a different MAC address. We start the virtual machine by highlighting the ISCSI_PVM2 in the list of virtual machines and clicking the star icon. So we choose this one and we may click in the star icon. Well, after that, we start the console for the virtual machine by highlighting the ISCSI_PVM2 in the list of the virtual machine and clicking the launch console icon. Is this one? Launch console. So the console window appears as a browser tab and the guest OS is booting. When the login prompt appears, we log in as root using the Oracle password. Notice that the virtual machine ISCSI_PVM2 retain the host name ISCSI_PVM1 of the virtual machine used as the source for the cloning process. We examine the configuration for Ethernet 0 for the ISCSI_PVM2 by using the ifconfig-a command. Well, note that the MAC address for Ethernet 0, it matches the information that you display in the step G. You see it's ended by 1B. The Ethernet interface did not acquire the IP address on the 192.168.1.0 net, the virtual machine network, because though the new machine obtained its own virtual NIC, the cloning process does not change any configuration files in the source clone. So you have to change the following files to fix the network configuration: the network file in the etc sysconfig directory to change the host name, and the ifcfg-eth0 file in the etc sysconfig network data scripts directory to change the MAC address. We display the ifcfg-eth0 file in the etc sysconfig network data scripts directory by executing the following commands. Note the MAC address assigned to ETH0 HWADDR. It does not match the MAC address assigned to ISCSI_PVM2. This is the MAC address for ISCSI_PVM1. You see that is not ended by 1B, it's ended by EB, right? So we need to shut down the newly created virtual machine by using the shutdown -H now from the command line. we exit the virtual machine console session by closing the browser tab of the console window. You return to the Oracle VM Manager system. So conclusion, when you clone a virtual machine, new virtual disks are created and a new MAC address are assigned to the clone, but the OS configuration in the clone is identical to the configuration of the virtual machine or template used as the source object during the cloning operation. You can modify the configuration of the cloned virtual machine to fix his problem, but it is an after-the-fact manual process. As an alternative, you can remove configuration information in the virtual machine that you plan to use for cloning. This unconfigured process does not provide initial configuration information to the virtual machines that you clone from the unconfigured virtual machine or template. The Oracle VM Guest Edition feature, for example, solves this problem by allowing you to configure a virtual machine to serve as a template. When you clone virtual machines from this template, the virtual machines enter a configuration wizard when they boot for the first time. In the next task, you clone a virtual machine from a template that is configured to trigger the first boot wizard by using the Oracle VM Guest Edition. This template was downloaded from the Oracle software delivery site. Most templates and virtual machines from this site offer the first boot configuration feature. So we clone a virtual machine from the OL6U5_ template located in the _repos1 repository. So we may click on the repositories tab. On the repositories tab, we expand the _repos1 folder, expand repositories, and in the navigation pane, and we highlight the VM templates folder. Now we highlight the OL6U5_ template file in the management pane and select the clone template icon in the toolbar. Is one. In the clone template window, we enter the selection summarized in the following table. Well, clone 2, we need to select to a virtual machine. This is virtual machine ready button. Clone count, we select 1. Name index level leave at 0. Clone name, we provide _PVM3. Description, we could enter something such as like virtual machine created by cloning the Oracle Linux 6 update 5 template. And in advanced clone, we do not select this checkbox. What your selection should look as follows: virtual machine, clone code 1, name index 0, _PVM3. Again, we have only one subpool, and virtual machine description, and the advanced clone deselected. We may click on OK to trigger the cloning operation, and the cloning operation takes 20 seconds or less to complete. We may click in the servers and VMs tab and display the virtual machines available in the pool 1 subpool. Okay, the pool 1 subpool, perspective, drop-down list, virtual machines. So now we have this, right? Virtual machine _PVM 3.0 appears in the list of the virtual machines in the pool 1 subpool. We make the following configuration changes to the _PVM 3.0 virtual machine. We highlight the _PVM 3.0. We select the edit button, and on the configuration tab, we make the following changes. We rename the clone to _PVM 3 by removing the extra characters in the name field. We remove the .0. We set the memory to 1024 megabytes. We set the maximum memory to 1024 megabytes. We set processors to 1, and we set the maximum processors to 1, and we set the operating system to Oracle Linux 6. We leave the restart action on crash at restart. Well, after that we may click on the networks tab, and for the assigned MAC address we select VM_net for the network drop-down list. So we choose this one. We click OK to trigger the changes to X86_PVM3. Okay, you see that the modified job and the different child jobs, okay, has been executed successfully. So we start the X86_PVM3 clone, we access to its console, and we respond to the configuration prompt. So we highlight the X86_PVM3 and we may click in the start icon. Okay, now show us the status of the starting. With the X86_PVM3 still highlighted, we may click in the launch console icon. Show the console window appears and the virtual machine is being booted. Notice that the following messages: entering non-interactive setup, starting OVM template configured. This message indicates that the template used for the cloning operation has the Oracle VM Guest Edition installed and that it has been configured for first boot configuration. Okay, you see the entering note and the starting the OVM template. Well, we need to enter the information when prompted as summarized in the following table. Do not press enter at the prompts. The example given are not defaults. So, first one about the network system hostname is X86 PVM3.example.com. For the network device to configure is ET80. For activate interface on system boot, we type yes. About the boot protocol, DHCP or static, we type DHCP. Remember that in previous practices you restarted the DHCP daemon because one of the servers is acting as a DHCP server to let, for example, to the virtual machine to get a dynamic IP address. And for the system root password, we type cangetting1 with C in uppercase and 1 as a number. Well, after entering the password for root, the boot process continues. Also note that you can ignore the field message that should appear, and we'll wait for the login prompt to appear. Notice that the virtual machine acquired the expected hostname, X86 PVM3, as specified during the force boot interview. Well, we log in to the virtual machine and we examine its network configuration. At the prompt login, we enter root, password, remember it was cangetting1 with C in uppercase and 1 in number, and we execute the ifconfig -a command to display the configuration information for the ET80 network interface. The virtual machine has acquired an IP address on the 192.168.1.0 subnet. In this case, this one, 254. Your IP address may be different than the one obtained in this example. Next time you boot this virtual machine, it will be prompt you for a configuration information. So we shut down the X86_PVM3 virtual machine, entering shutdown -h now command at the prompt line, So the ISCSI underscore PBM 3 virtual machine shuts down and the process takes less than a minute to complete. And we close the window by closing the browser tab. And that's all for practice 3.1. Practice 3.2, we examine the components of a virtual appliance. In this practice, you examine the structure and components of the virtual appliance present in the ISCSI underscore repos1 repository. You also examine the components of the template that was created from this virtual appliance. Assumptions. This practice assumes that the following objects are already present in your environment. A virtual appliance called OVM underscore 006 U5 underscore X86 underscore 64 underscore PBM.OVA. This virtual appliance contains a virtual machine with Oracle Linux 6 Update 5 installed. A template named OL6U5 underscore template. This template was created from the OVM underscore OL6U5 underscore X86 underscore 64 underscore PBM.OVA virtual appliance. Well, for tags, so first of all, we access the directory where the OVM underscore OL6U5 underscore X86 underscore 64 underscore PBM.OVA virtual appliance is stored. We go to terminal and we log into your lab machine and change your user to a root. So su minus, and we provide the password as instructed by the instructor. From your lab machine desktop, we start a session to the ovsvr02.example.com OVM server by using the SSH command. If asked to continue with the connection, reply yes to store the RSI key for ovsvr02.example.com in your list of known hosts. The member password is Oracle. Well, we need to execute the df-h command to list the amount points for the configure repositories in your Oracle VM repository. With Control-O, we clean up the screen and we see this, right? Well, you see that the ISCSI underscore repos1 repository is the repository with the 56 GB size. Is this one. This is the repository where the OVM underscore OL6U5 underscore X86 underscore 64 underscore PBM.OVA virtual appliance has been imported previously. We change the directory to this repository and we list its contents. So we could copy this entry and we navigate to this directory. And now we list the contents with the ls-l command. Note that the command line prompt was shortened to show or to allow the command to fit on a line. Well, we change the directory to assemblies and we list the contents of the assemblies directory. With the cd command, we get into the directory with the ls-s, we list the contents. There is only one file in the assemblies directory. 11E3C3B4C8. This is the file is the ID of the virtual appliance, the OVM underscore OL6U5 underscore X86 underscore 64 underscore PBM.OVA. You see in the Oracle VM Manager user interface. We examine the contents of the virtual appliance. We change directory to this virtual appliance and we list the contents of the directory. So you will see, okay, this file. A virtual appliance has the following parts in the directory. The virtual appliance file as initially downloaded. In this example, this is the package.ova. This is the file that has the same size as the OVM underscore OL6U5 underscore X86 underscore PBM.ova virtual appliance file. And unpacked directory where the components of the virtual appliance are stored as they are being unpacked during the import operation, and import directory that is not used at this time. We examine the files that make up the package.ova virtual appliance by using the tar command with the tbf options. We list the files in the unpacked directory, so you find in this directory the same files that were listed as part of the virtual appliance content in the previous step. A virtual appliance contains the following files: .obf file. This file contains the metadata for the virtual appliance package. The package is built according the Open Virtualization Format, or the OVF. .mf file. This is a manifest file that contains the SHA-1-1 digest for the files in the virtual appliance, and a file named system.img. This file is a virtual disk in raw disk format. There can be more than one virtual disk in a virtual appliance. Well, next step number 3, is examine the files in the virtual appliance. We use the cat command to examine the .mff file. The .mf file is a manifest that contains the SHA-1 digest for the files in the virtual appliance. We use the more command to examine the .off file. Well, there is only one .off file in each virtual appliance. This is an XML file that describes the components of the virtual appliance. It is created by the utility that created the OVF package. Use the Q subcommand to exit the more command. Now we use the file command to examine the structure of the system.image file. When you create a virtual appliance, the virtual disks in the virtual machines that make up the virtual appliance are compressed. When you create a template from a virtual appliance, the virtual disks that are part of the virtual appliance are uncompressed and stored in the target repository. Find the virtual disk that was created from the uncompressed system.image file when a template was created from the OVM_OX65_X86_64_PVM.ova virtual appliance. We change directory to the templates directory and we list the contents. What we to do is show we navigate to the templates and we list the contents, right? We change the directory to the only template in this repository and we list its contents. We find the location for the system disk that is specified in the vm.cfg file for this template. With this command grep, we're able to find where is this system disk. Note that the path for the virtual disk follows the file column prefix and ends with the comma. We list the virtual disk for the template by using the ls-l command and the path of the specified file in the vm.cmd file. When the virtual appliance file was uncompressed, to create a template, the system.image file expanded from 512 megabytes to 12 gigabytes. We display the virtual disk structure by using the file command. The file command reveals that the virtual disk is a bootable system disk with 3 partitions. Terminate the system, the SSH system to obsvr02.example.com by using the exit command. Creating templates for virtual machine components. You can create your own template by assembling a virtual machine configuration file and one or more virtual disks. One of the virtual disks must be bootable. You then use the utility to create a .tgset file, such as the tar command, and you can then import this template into the Oracle VM environment. Creating virtual appliances, you can obtain or create a virtual appliance by downloading an Oracle VM virtual appliance in .ova or .obf format from the Oracle Technology Network portal and importing into the Oracle VM Manager, or expanding an existing virtual machine as a virtual appliance in the Oracle VM Manager. You see the section 4.7.2 about exporting virtual machines to virtual appliances for more information, and that's all for practice 3-2. Practice 3-3, we use the P2B utility to create a new template. In this practice, you create a template by using the P2B utility. With this utility, you can capture the disk content of a physical or virtual host into a template by transferring the physical disk of the physical host or the virtual disk of a virtual host over an HTTP connection into components of a template. When you use the P2B tool to capture the content of a host into an Oracle VM template, your host goes through several stages. Boot process. You boot your physical or virtual host by using the Oracle VM server for X86 installation CD or ISO file. Network configuration. You provide information to configure a network interface. Disk selection. You select which disks are transferred to the template. A web server is started in the host. Import operation. You start the import operation from the Oracle VM Manager user interface and specify the files as listed from the web server on the physical or virtual host, and ending the transfer. From the console of the physical or virtual host, you use Ctrl+C to end the transfer. We have some assumptions. In your lab environment, you use a virtual host for this practice. The virtual machine named host01 runs directly on your lab machine at the same level as your Oracle VM servers and your Oracle VM Manager virtual machines. The host01 virtual host has two virtual disks, one system disk of 2 GB of size, system.image, and one swap disk of 1 GB of size, the swap.img. For this practice, you only transfer the system disk. You do not transfer the swap disk because the virtual machine can run without it. Well, for the first step, we prepare the environment for the P2B operation. We need to verify that all the virtual machines in your Oracle VM environment are in the stop state. If there's a virtual machine running, shut it down by using the Oracle VM Manager user interface or the Oracle VM CLI. Well, we first of all check again, you see in servers and tabs, that all the virtual machines are stopped. Now we shut down the obsvr0.example.com server by right-clicking on this server in the navigation pane and selecting Stop in the shortcut menu. Click OK in the confirmation window. Note that the Oracle VM server stops and a red icon appears next to it. There is no critical event generated for the stopped Oracle VM server because it was stopped by the Oracle VM Manager, not a shutdown command issued, for example, from a Oracle VM server or a failure that we have in the server, right? Well, we need to locate and start the host01 virtual machine from the Oracle VM server for X86 ISO file present in its vm.cfg configuration file. So we start a new terminal window in your remote host lab machine. We change as root. We provide the password for root. And we access to the OVS running pool host01 directory where the components of the host01 virtual machine reside, and we list the directory's content. We start the host01 virtual machine by using the xmcreate command from the OVS running pool host01 directory. Without delay, we access the console for host 01 by using the VNC viewer command. So we are here. With the initial screen appears, we enter P2B at the boot column prompt and we press enter. The P2B utility continues to boot a few seconds before the disk found window appears. So you see a screen indicating that the utility is waiting for the network manager to configure the ETH network interface. Since host 01 has only one network interface, the network manager automatically configures it. If a host has more than one network interface, the network manager prompts you to select one and then configure it. If the network manager cannot successfully configure a network interface, you are prompted to configure the TCP/IP settings manually. Well, we respond to the prompts from the P2B utility. On the disk phone window, we press tab to highlight the skip and press enter. On the disk selection window, we press enter on the arrow down key to select SDA, which is the system.img disk. We ensure the location of the asterisk. Do not select SDB, which is the swap disk. Well, after that, on the disk selection window, press enter and we press on OK. Well, on the window to select the other parameters for the template, we enter the values as summarized in the following table. Well, about the VM name is host 01 underscore template. For the VM memory megabytes is 1024. For the virtual CPUs is 1. And for the console password and confirm console password is Oracle. We press tab to highlight OK and we press enter. The P2B program starts a secure web server in the host and displays the IP address and port number of the web server. This is in preparation for the template transfer. Well, the next step, step number 5, we need to access a web server at the location specified on the console. In this case, is this IP 2.254. So from the labs machine desktop, we open a web browser window by double-clicking the Firefox web browser. We have this one. And we enter this path in the URL file, https://192.0.254. You can omit the port because 443 is the default port for the HTTP access. This is the web server address shown in the message display by the P2B tool in the tags 4D. Note that if the web server is running from an IP address other than 192.0.2.154, try using 192.0.2.253. In the Entrusted window, we click Understand the risk. We may click on Advanced. We add an exception. We get the certificate and we confirm the security. Note that if the confirm security button is disabled, we need to press enter. The new window appears and displays a directory listing the host 01's system disk and configuration file. You use these two files in the next step. So we see here we have the system image file and the configuration file. Important in a later step, when referring to the system disk to transfer during the import operation, we need to use the name system-sda.img. We launch the import operation from the Oracle VM Manager user interface and we prepare to view the log file from the Oracle VM server. So we go here Well, if you don't have an active season to the Oracle VM Manager user interface, start a new one. So for example, for a terminal window on your desktop, you change user to root, you access the OVM MGR01 by using the SSH command with the -X in uppercase option. From the OVM MGR01, we start Firefox with the Firefox space -no-remote & command. In the Firefox window, we access the Oracle VM Manager user interface by entering the following URL: https://localhost:/7002:/OVM/console. We log into the OVM Manager user interface with the user admin and the password myOracle1. Well, in the Oracle VM Manager user interface, we click the repositories tab and we access the VM templates folder for the X86 repository in the navigation pane. So we go to repositories, we expand repositories, and in the X86 repos, okay, we put focus on the VM templates. In the management pane, we start an import operation by clicking the import VM template icon. Is this one. Well, in the import VM template window, we need to enter an HTTP path for both the system-sda.img disk image and the vm.cfg file discovered by the P2B program. We use the HTTP address that was displayed previously on the console of the P2B program. In this example, the address is https://192.0.254. So we add the URL for the disk image, system-sda.image, which is this one, https://192.0.254/system-sda.img, and we press enter, and we add the URL for the configuration file vm.cfg, which is https://192.254/vm.cfg. Do not click OK at this time. Leave the windows as is. You return to the window in a later step. From a terminal window on your lab machine, we start a new SSH session to the Oracle VM server that is being used for the import operation. In this example, the Oracle VM server OVS SVR01 is selected to perform the transfer. So we minimize this window and this soda. We open a new terminal. And we log into the OVS SVR01 server. Well, we access the barlog directory and we start a -f command to view the ovs-agent.log file as it is written to. You can safely ignore the error messages that are issued because the OVS svr02.example.com is down. Well, I'm gonna try to resize to view better, right? So these are the examples. So we return to the web console to import a template, and now we may click on OK to start the transfer. So the new job is scheduled, so we could monitor the import operation from the P2P program console, the Oracle VM Manager user interface, and the Oracle VM server log file. We'll monitor the import job from the Oracle VM Manager user interface, so you see that an import jobs displays in the Oracle VM Manager. And also we could monitor the import job from the console of the P2P program. So an HTTP GET operation is started from the OVS SVR example.com, the server that was selected to import. But also we could monitor the import job by viewing the log for the Oracle VM server performing the import operation. So if we go here, you will see that you get messages like this one. It's in progress, it's downloading. And it's still running. Even if the import job is still running, we create a 4 GB virtual disk in the iSCSI_repos1 repository. You use this virtual disk in the next slide. So we go to the Oracle VM Manager in which the job is running, and now we go to the repositories tab, and we select virtual disk folder under the iSCSI repos1. In the management pane, we click the Create Virtual Disk icon in the toolbar. So we need to specify the following information for GB_vdisk as the virtual disk name. We set the size of the virtual disk to 4 GB, and we select non-spare allocation from the allocation tab drop-down list. We may click OK to create the virtual disk. The job to create the virtual disk completes. So you see now you have running the job for importing the template, and also we have for the physical matching, and we have running this. Well, the import job continues, and the import takes 25 to 30 minutes to complete. While the import job is still running, we start the iSCSI_PBN3 virtual matching. Well, so in the servers and VMs tabs, we highlight the pool 1 in the navigation pane. And for the virtual machines, we select virtual machines from the perspective drop-down list in the management pane. And now we may click the start icon in the toolbar. Well, after that, we start the console for the iSCSI_PBN3 virtual machine by clicking the launch console icon in the toolbar. So the iSCSI_PBN3 virtual machine boots. Note that the iSCSI_PBN3 virtual machine boots slowly because the OVS SVR01 Oracle VM server is busy running the P2B import. When the login prompt appears, log in to the iSCSI_PBN3 as root with password cangetting1. We need to get log as root cangetting1. So we display the disk in this virtual machine by using the fdisk-L. Well, this virtual machine has a single disk XVDA with multiple partitions. We display the IP address obtained by the iSCSI_PBN3 by using the ifconfig-a command. Make the note of the IP address. In this example, the IP address is 192.168.1.252. Your IP address may be different. We close the console for the iSCSI_PBN3 virtual machine. Well, for me, I'm going to take note of this one, 254. And we close the console. Well, after the import operation completes, we kill the host 01 virtual machine that was used for the P2B process. We use the xmdestroy host 01 command to terminate host 01 immediately. Well, we need to check that the import operation was successfully executed. So in a terminal, connected to the host. Remember, we have this host running and we want to destroy this one, to stop this one. Okay. Note that the stop to host 01 virtual host virtual machine to Ukraine is resources. This virtual machine acting as a physical host for the P2P procedure is no longer needed. From your OVSVR01 Oracle VM server system, we terminate the tail command by pressing the Ctrl+C, and we enter the exit command to return to the lab machine. We terminate the web browser session to the web browser that was started by the P2P Chrome program in the host 01. This is the browser window that shows the directory listing for host 01 at 192.0.2.254. So this was the previous screen. You see that I press Ctrl+C here, okay, and I get exit from the, and this is the other window about directory listing that also told us to close. On the repositories tab, we display the name new template created during the P2P process by highlighting the VM templates folder in the navigation pane. So we go to repositories tab. In templates, we have this system.sda image file. So the template is called system-sda.image. We edit your new template, so we select the template and we may click on edit. And the configuration type, make the following change. First of all, about the VM template is host 01 underscore template. For the operating system, we choose Oracle Linux 6. We select USB tablet from the mouse device type drop-down list. And we select send PVM from the domain type drop-down list. Well, it should appear like this one. Host 01 underscore template, Oracle Linux 6, USB tablet, send PVM. Now we may click on the networks tab and we remove the undefined network from the list of selected Ethernet networks, and we add the VM underscore net. You can skip the disk tab as no changes is needed. Well, we may click on the boot order tab, and this is the default option if nothing is specified, and we add disk to the boot order pane, and we may click OK to complete the edit operation. And we may click on OK. Well, so a new job is executed and the operation finished successfully. Now we're going to create a virtual machine from the new template, and we verify this configuration. So we select this host 01 underscore template, and we may click on the clone template icon, this one. In the clone virtual machine host 01 underscore template window, we enter the selection as summarized in the following table. About clone 2, we select to virtual machine ready button. About the clone count, select 1. About the name index, we leave at 0. About the clone name is X86 underscore PVM4. This is the subpool. Description is optional, and we advanced clone, we do not select this check option. We may click on OK to launch the cloning operation. Now we may click on servers and VMs tab from the Oracle VM Manager, and we find your newly cloned virtual machine X86 underscore PVM 4.0. We highlight this X86 underscore PVM 4.0, and we click the display VM configuration file content icon. Well, you cannot view it. Okay, you have here Well, note if the display VM configuration file content does not appear, click the double arrow at the end of the toolbar to display the additional icons. We scroll through the configuration file to look for the bootloader. So you will see that it shows as user bin pgroup is correct for the PVM-type virtual machine. The disk entry is shown as HDA, which is an entry for the HVM-type virtual machine. So we have this as the bootloader, and this is for the disk as the HAD type. So we make click on OK to close the VM configuration file contents, the ISCSI _ PVM 4.0 window. Conclusions: the configuration file created for ISCSI _ PVM 4.0 is not valid for your lab environment because virtual machines running on your Oracle VM server must run as PVM guest. This limitation is because your Oracle VM servers are virtual machines that don't support virtualization, hardware virtualization assists. Workaround: we delete the ISCSI _ PVM 4.0 virtual machine. Do not delete the virtual disk that was created by cloning host01 _ template, and we create a new virtual machine and use the virtual disk that you preserved in the former ISCSI _ PVM 4.0 virtual machine. You create the new virtual machine as a PVM guest. No, because the host01 machine used for the P2B tool runs Oracle Linux 6 with unbreakable enterprise kernel. The virtual disk imported from host01 as part of the P2B operation can run as HVM with PV drivers, or PVM guest without having to make changes to the Oracle Linux OS. Well, to delete the current ISCSI _ PVM 4.0 virtual machine and creating a new virtual machine called ISCSI _ PVM 4 and adding the virtual disk retained from the former ISCSI _ PVM 4.0 virtual disk, we follow the following steps. We highlight the ISCSI _ PVM 4.0 and we click the delete icon, this one. We leave the checkboxes deselected and we may click on OK. Well, we need to deselect because remember you remove the virtual machine, but you don't want to remove the image files. So we may click on OK. In the navigation pane, we click the create virtual machine icon. Here's this one. And we select the create new virtual machine ready button in this window and we may click on next. Well, on this create virtual machine window, we enter selections as summarized in the following table. Subpool is pool 1, about server is any, repository is ISCSI _ repos 1, enable high availability is not selected, about the name enable high pages is not available, right, is disabled. About the name is ISCSI _ PVM 4. Well, for description, this is optional. About the operating system is Oracle Linux 6. The mouse device type is USB tablet. About the key map is we select the appropriate. For example, we are using this keyboard, right? The domain type is SAM PVM. Start policy is the best ever. The maximum memory is 1024. About CPU maximum processors is 1, the priority 50, processor cap percentage 100. So we may click on next to continue. In the setup network windows, we click add VNIC and select VM _ net from the network drop-down list. So we make add VNIC with the network VM _ net. We may click on next. In the arrange disk windows, we select virtual disk as the disk type in the slot 0 and click the search icon to find the virtual disk created by cloning host 01 underscore template. So we choose virtual disk and we may click on the search icon and we choose the disk that we created during the clone operation of the host 01 underscore template physical machine. Well, so we have system-sda.image. We may click on OK. So we go back to the arrange disk window and we may click on next to continue. In the boot options window, we select this as the boot option. And finally, we may click on finish to complete the creation of the ISCSI_PVM4 virtual machine. Well, so we start a job, okay, doing show. Well, next step 14 is to restart the ovsvr02.example.com Oracle VM server. You stop at the ovsvr0.example.com to allow host 01 to acquire enough memory to boot in your environment. So in a terminal window in your lab machine, we switch to the root user. For example, this one, if not yet already done, right? And we need to access the directory where the vm.cfg file for the ovsvr02.example.com is located. So we go to the OBS running. Here we have the VM. So we say xm create vm.cfg. So the domain ID for the ovsvr02 may be different in your environment, no problem. Note if you get a message about hot plug scripts not working, wait for 1 minute and re-execute the xm create vm.cfg command. Okay, it works fine for me. So I go back to the Firefox web browser season and we should view that the VM server is been starting, all right, and for the server pool, okay, that the virtual machine is running. Well, next step is to start the ISCSI_PV4 virtual machine and access its console. So in the Oracle VM Manager user interface, we click the servers and VMs tab and we locate the ISCSI_PVM4 virtual machine. Well, in this case, we have here, we have pool in the perspective drop-down list virtual machines. So we have this one and we may click on the start button. Well, we start the console for the ISCSI_PVM4 virtual machine by clicking the launch console icon. Okay, we wait for this running and now we launch the console. Well, you should be able to view the boot process and we wait for the login prompt. Now we log in to the root account and we use the Oracle password. Well, display the network information by using the ifconfig -a command. This virtual machine boots successfully, but the ETH0 does not acquire an IP address. This is due to the fact that the configuration information for ETH0 still points to a different MAC address. This is the same situation that you experience after cloning a virtual machine. This situation can be fixed by updating the networking configuration of the virtual machine. You do not perform this step at this time. We close the console window for the ISCSI_PVM4 and we read the post P2B cleanup section and then we proceed to task 16. The post P2B cleanup of templates virtual machines produced by the P2B tool. This template produced by the P2B tool and the clones created from this template often need to be manually updated to fix the following problems: invalid entries in the vm.cfg file, invalid network configuration, outdated OS that might not support paravirtualized operation. For example, if the physical host used as the source machine for the P2B tool runs a Microsoft Windows OS, a virtual machine clone from the resulting P2B template is created as a HVM type guest. You can install the Oracle VM paravirtualized drivers in the guest OS and convert the domain type of the guest to send_HVM_PB_ drives. Shut down the ISCSI_PBM for virtual machines. So in the Oracle VM Manager user interface, we may click on servers and VMs. We locate the pool, for example, with perspective virtual machines, the ISCSI_PBM4 in the server pool for pool 1. We highlight the ISCSI_PBM4 virtual machine, and when we click on the kill, you have this one, stop and kill. This is what we want, right? Now this kill action halts the virtual machine immediately. We may click on OK to confirm this. And that's all for practice 3-3. Practice 3.4, add a virtual disk to a running virtual machine and resize the virtual disk. In this practice, you add a virtual disk to the virtual machine, ISCSI_PBM3 that you created in the previous practice. You then resize the virtual disk from 4 GB to 5 GB. In your virtual machine, you force the OS to recognize the new size for the virtual disk. Well, first one, task 1, in the Oracle VM Manager user interface, we display the status of your virtual machines. So we may click on the servers and VMs tab. We select pool 1 in the navigation pane, and we select virtual machines from the perspective drop-down list. So the only running virtual machine must be ISCSI_PBM3. If you have other running virtual machines, stop them at this time. We access the ISCSI_PBM3 from your lab machine. So we click the span button next to the ISCSI_PBM3 and we click the Networks tab. On the Networks tab for the ISCSI_PBM3 virtual machine, we examine the IP address assigned to the ETH0 network interface. This IP address matches the IP address that you note for the task 9F in practice 3.3, titled Use the P2B tool to create a new template. From a terminal window on your lab machine, switch user to root and use the SSH command with the IP address assigned to ISCSI_PBM3. The root password for the ISCSI_PBM3 is cangetin1. So we open a new terminal. We could take one of these terminal, for example, already open, and we use SSH 192.160.1.154. We type yes, and the password, remember, is cangetin1. So we are going to add a virtual disk, the 4GB_B disk, to the ISCSI_PBM3 from the Oracle VM Manager user interface. We click the servers and VMs tab. We highlight for the pool 1 perspective virtual machines the ISCSI_PBM3 virtual machine, and we may click in the edit icon. In the edit virtual machine ISCSI_PBM3 window, we click in the disk tabs. Note your virtual machine's ID is different, right? In the slot 1, we select virtual disk from a disk type drop-down list, and when it appears under actions, we click the search. So we choose virtual disk, and now in the actions we may click in the search icon, and we select the virtual disk named 4GB_B disk that you created in task 8 in the previous practice. We may click on OK. And we're back in the edit button. We may click on OK to complete the changes to your X86-PVM3 virtual machine. Well, you schedule a job about editing the VM, sorry. So now we verify that your virtual machine can see the new virtual disk. So from your active SSH season to X86-PVM3, we run the fdisk -l command. Well, now we should be able to view the new disk, the XBDB, in addition to the previous one I showed you before, okay, the XBDA of 4 GB, right? We use the tile command to view the last entries in the var log messages. Tile var log messages. Well, the virtual disk XBDB has been discovered. You see that appear messages about the XBDB. Well, to increase the size of the 4 GB underscore disk to 5 GB and examine the results in the X86-PVM3 virtual machines. Note, you can only grow virtual disks, you cannot shrink them. From the Oracle VM Manager user interface, click the Repositories tab, and then use the expand button next to the X86-repos1 folder to display its contents. Well, if it's not already, we need to select virtual disks in the navigation pane, and we highlight the 4 gigabits underscore bdisk in the management pane, and we may click in the edit icon. Well, we need to change the size from 4 to 5, so we enter 5 in the size field, and we may click on OK to resize the virtual disk. Well, we need to select the non-sparse location from the resize action drop-down menu, and then click OK to complete the action. Well, from the SSH season to the X86-PVM3, we examine the messages file for messages about changing disk. So we repeat again and again the same array, and you will see that setting capacity to detected capacity chain. Okay, this is the message that we expect. So the last message is about finding the XBDB disk. There are no new messages about the chain in this disk size. Well, we run the fdisk -l command to see if there is any chain to the size of the virtual disk. So we see that now the disk show us or reports the size of this dep XBDB to the 5. Well, we force the visual matching to recognize the new size of this dep XBDB virtual disk. Well, it's important to not execute step 6 if you have not completed the P2B exercises in the previous practice. Step 6 assumes that the X86-PVM4 virtual machine has been shut down and that the Oracle VM servers obsvr02.example.com has been brought back up. If you are not completed the P2B practice, return to task 10 for practice 3-3. Title, use the P2B tool to create a new template. When resizing a physical disk, that is a virtual disk with a physical disk backend, you can use a SCSI rescan action to force the virtual machine to recognize the new disk size. SCSI rescan does not work with a virtual disk located in a repository. There are several ways to force a virtual machine to recognize the one of its virtual disk has changed. For example, rebooting the virtual machine or unmounting any file system mounted to partitions on the virtual disk, and use the Oracle VM Manager user interface of CLI to remove, not delete, the virtual disk from the virtual machine's disk configuration. Then re-add the disk to the virtual disk to the configuration. Migrate the virtual machine to another Oracle VM server. Also, it should be another way. Well, in these tags, you use the live migration method. So know that migrating a rolling virtual machine is called live migration. There are requirements for a live migration to be successfully, such as CPUs in both the source and target Oracle VM servers, must be from the same family of processors, and the processors must be of the same model. Another requirement is that the Oracle VM servers involved in the migration must have access to the same shared storage. So from the Oracle VM Manager user interface, we may click the Servers and VMs tab, and we locate the ISCSI_PVM3 virtual machine from the listing of all the virtual machines. So the VM servers, pool, virtual machines perspective. All right, we select the ISCSI_PVM from the list of virtual machines, and we may click the migrate or move icon. In this case, is this one. On the migrate or move virtual machine ISCSI_PVM3 screen, we click the migrate a running VM to a different server within the same server pool. Ready button, and we may click on the next. On the next screen, we select a target to migrate the virtual machine to. Note that if the ISCSI_PVM3 virtual machine is currently running on the obsvr02.example.com, the migration specifies the obsvr01.example.com as a compatible server. Well, obviously, because it's running in obsvr01 in this example, okay, we are going to migrate to this other. Well, we may click on finish, and we start the live migration process. The migration process takes about 3 minutes to complete, and during the migration operation, your SSH session to ISCSI_PVM remains active. Note that you can follow the progress of the migration operation from the Jobs tab. You see now it's running. This is the job, and it shows us that it's running. Well, after the migration operation completes, we reuse the fdisk-l dep xbdb command from the SSH session to the ISCSI_PVM3 to view the disk size for the dep xbdb, and you will see that the disk is now of 5 GB instead of 4. If the disk size still is 4 GB, perform step F. Well, if the migration failed, to refresh the size of the dep xbdb, we restart the ISCSI_PVM3 virtual machine by entering the shutdown -r now command at the ISCSI_PVM3 command prompt. After the virtual machine has rebooted, we restart your SSH session to ISCSI_PVM3. We log in as root with the password of cangeting1, and we reissue the fdisk-l dep xbdb command. The size is now 5 GB. In many cases, you can use live migration to force a virtual machine to refresh the size of a newly resized disk. Because your environment is virtual, this process does not always yield the expected results. You can now use disk and file system procedures to force any system on the disk to use the entire virtual disk, rather than use the 4 GB it is currently using. These procedures are outside the scope of this course. A better practice when adding disk capacity to your virtual disk is to use the logical volume manager to manage your file systems. With LVM, you don't need to resize your partitions at the OS level. You must add more virtual disks and add these virtual disks to your volume groups as physical volumes, and then you expand your logical volumes. After a logical volume is expanded, you can use utilities such as resize2fs to grow your file systems. Well, after that it's finished. You see that's the way. For the cleanup, we use the exit command to terminate your SSH session to the ISCSI_PV3, or we close the window. We click Logout Global link in the Oracle VM Manager user interface to log out of your user interface session. So we may click on the logout. We close the Firefox window, and we execute the exit to close all the different terminals that we have already opened. Also remember you could use the Ctrl-D. Well, and that's all for practice 3.4.